Welcome back to BSpice. Under technology series, we'll focus on sensor aging. So this is more of a to determine the sensor aging. Okay, what are all the procedures involved? How we are going to detect, and what are the parameters we need to consider for this sensor aging. All those we will see in this session. Okay. So under heartbeat monitoring, uh, sensor aging. So meaning identification of sensor aging and remaining sensor lifetime. Okay, this is for all transmitters. So what is the impact on the device if we don't do this, identify the sensor aging? Of course, device performance or remaining lifetime could be affected. And what are all the benefits we can attain out of this heartbeat technology? Of course, increased reliability, process availability, safety by early detection of deterioration of sensor health or lifetime. So that is the point. Then it enables maintenance intervals to be optimized. Then what are all the parameters we need to define this? See, for level, we need expected source operating time. Okay, remaining useful lifetime of the photo multiplier. Okay, then analysis measurement. This is means for analyzer sensor health index like pH, ORP, dissolved oxygen, disinfection, all these. So device health index also needed for analysis. Okay, liquidation, liquid samplers. And for temperature, measurement of temperature deviation we need to consider. So basically these are the parameters which we need to consider for this sensor aging. Right. So let's see how it works. For level, radiation sources, decay over time, isn't it? So for radiometric level measurement device, this practically means that the amount of radiation arriving at the detector reduces over a period of time. Okay, so device automatically compensate for this effect to large extent, but if the radiation falls below a certain level, okay, the measuring reliability may be compromised. To estimate the expected remaining operating time, the detector evaluates whether the source activity is still strong enough to achieve the specified measuring accuracy. So this provides increased confidence in measuring reliability and optimally timed information on source replacement. As you can see here, this is the source activity radiation, right? So this is in years actually. You see here, this is 50% after one half-life. So this is the source replacement recommended because the limit is application dependent here. So this is the what you call the value where it source replacement is recommended. So once this value attained, then we need to replace this. So this is how it works for the level. Okay, then we will see how it works for temperature. In temperature, we have one trust sense. So as the self-calibration temperature of the RTD sensor is recorded and stored in a memory, any deviation over the time can easily detect it. If a predefined limit is reached, both the diagnostic message and proposed remedy actions are provided. So as you can see here, this is the temperature at a self-calibration point. This is the temperature, and this is all your, time actually. So if you see the curve, you see the warning here, and this is out of range already. So this is your out of range, and this is your warning here. So once a predefined limit is reached, actually, both diagnostic message and proposed remedial actions are provided. Here, this is the self-calibration actually. So conventional calibration, example, prescribed by the law. Okay, so this is how it actually. So again, friends, this is just for your info only. Maybe more of awareness. If you want to utilize this, you can make use of this technology. Thank you. Bye bye. Take care.